we're going to talk about areas of parallelograms and triangles. We're starting a new section all about area, and we're going to be covering lots of topics about area of different shapes and how to remember that, and just really large unit on area. So we want you to learn how to find the area of any parallelogram. Remember, there are several different types. And we want you to also learn to find the area of any triangle, and there are also several different types of those. Thankfully, all of this is easy. So what do we know about the area and perimeter of rectangles? Well, we know that the area is equal to the base times height. We know that with perimeter we can just add up all the lengths of the sides. And remember, a rectangle is one of the most restrictive types of parallelogram, okay? So if we know the base, and we're going to introduce a few terms here, base being something that, imagine you could sit it on a table or something like that. So we have two bases here, right? And we have two heights. And based on the properties of a rectangle, we know that the bases are parallel, the heights are parallel to each other, and they will be different values. Or they might be the same, but, Anyways, regardless, the area is the base times the height. So we can just say our base is 9 and our height is 3. Our area would be 9 times 3, and that would be 27. Now we haven't talked units yet. So if this was 9 centimeters times 3 centimeters, really that is 9 centimeters times 3 centimeters, which leaves me with 27 centimeters squared. Centimeters times centimeters is centimeters squared. So our area is going to be in square units, whatever those units are. Let's talk about the parts of a parallelogram now. Here we also have bases and heights. Here is a base, here is a base. But with a parallelogram, we don't have the 90-degree angles that we have with a rectangle. So our height is going to be the distance between our bases. Okay? The distance between those parallel bases is our height. We're going to do some activities in class probably that will help illustrate why the area of a parallelogram is just base times height. But the nice thing is that all the different forms of parallelograms take this. So we can have a square, we can have a rhombus, we could have just a regular parallelogram, we could have a rectangle, right? Any of these forms of parallelogram can use the area equals base times height formula. So let's find the area of this parallelogram. So here we have 9 centimeters times 4 centimeters. Our area is going to be base times height again. So that will be 9 centimeters times our 4 centimeters, which will give me 36 centimeters squared. Okay? Pretty easy on this stuff. So let's find an area of a parallelogram in the coordinate plane. Well, that is actually kind of an easy thing to do, especially if we give you nice integer based vertices, which we've done here. So we have point A at 2, 3, point B at 4, 7, C at 6, 3, and D at 8, 7. And we want to know the area of this parallelogram. Well, we can see that our bases here each have a length of 4 units. And though we can connect our vertices here to form the parallelogram, we can also see that the height here is also 4 units. So my area is just going to be 4 units for my base times 4 units for my height, so 16 units squared. Okay. So here we want to find some missing dimensions. And the missing dimension we want to find is this dimension here, BF. Okay? So we can do this using area of a parallelogram. And what I'd like you to do is look at the parallelogram and see what we've got. We've got a base right here, but we don't have a height. But if we kind of flip this over in our minds, this AB can become a base and EC can become a height. Okay? So my area equals base times height still. But in this case, I'm going to define that base as base AB and my height as the segment EC. Okay? So that leaves me with an area of 15 inches times 12 inches. Pulling out our handy dandy little calculator here. So we know that it's going to be more than 144. That is 180 inches squared, right? Now, if we use this as a two-step problem, and now we know the whole area of this parallelogram, right? We know the area of this parallelogram. Now we can use that area and this dimension here to find our height. So area, in this case, we'll define as the segment AD times the segment BF. Now keep in mind, BF is really what we need here. So I will know that 180 inches squared should equal the AD dimension, which is 13 inches, times the segment BF that we really is what we're looking for. So that segment length BF should equal 180 inches squared divided by 13 inches. Which ends up BF is a segment that's about, the little squiggly equals here, because it means about, we're approximating here, 13.84 inches. Okay? So that is the segment length for BF that we did not know. Okay? We used a two-step process here to figure out what our area was and then use that area to find a missing segment length. Now let's talk about area of a triangle. Now we have to note here that a diagonal divides any parallelogram into two congruent triangles. Therefore, the area of each triangle is half the area of a parallelogram. Well, the area of our parallelogram was just base times height, so that we know that any triangle will be the area of 1/2 the base times the height. Because if we put two of those identical triangles together, they would form a parallelogram. Always, always, always. So that's how we derive the area of our triangle. So if we know that our base is like 3 centimeters, and we know that our height is 4 centimeters, my area will equal 1/2 my base, which is 3 centimeters, times my height, which is 4 centimeters, which is 6 centimeters squared for that total area. Okay? So if you can find the area of a parallelogram, you can find the area of a triangle. So let's find the area of a triangle together. Here I've drawn in some dimensions. We have a base length of 7 inches and a height of 10 inches. So my area is going to be 1/2 my base, which is 7 inches, times my height, which is 10 inches. So that will be 1/2 of 70, which is 35 inches squared for that area. Again, the math here is pretty easy for now. Yeah, of course, it always gets more difficult because otherwise, why would you be in the class? So here's what we've learned. We can find the area of any parallelogram using the formula area equals base times height. We've learned that the area of any triangle is half the area of the parallelogram, so the area of a triangle is 1/2 base times height. See you in class.